Hi, my name is Oluwaseun Martins, and in this video, we're looking at the Numpy library in Python. The Numpy library is one of the libraries in Python that is used particularly to solve scientific problems or scientific computing in Python. So if you want to do any scientific calculation in Python, or you want to work with arrays particularly, maybe one dimension, multi-dimensional arrays, you'll be needing the Numpy library. So without wasting time, I'll just switch to my Jupyter notebook, and we'll be looking at the Numpy library. So once you have the Numpy library installed on your system, probably on your Anaconda, or you just install it through the terminal on your Python, you can have Numpy library. So is a library that you use to solve scientific computing in Python, and the way you would do it is just the same way with other libraries. For you to use any library in Python, you need to import that library first of all. So you use the keyword import, then the library name. Now every library in Python, in most cases, they have like an alias or a nickname by which you can record that library as you go along in your program. So for Numpy, it is referred to as NP. So you say import Numpy as NP. Now you can import it as anything you would like, but the thing is, globally, Numpy is always import as NP. So just to keep the best practice in place, so you can just import it also as NP. So whenever you want to use Numpy within your code, all you need to do is to use the word NP. So far you have already done this line before calling the Numpy library. So the first thing, you just run this line. So it might take some few seconds. So this took just 0.9 seconds to import Numpy as NP. So what you will want to do with Numpy is to create single dimensional arrays, or you want to work with arrays, or you want to create multi-dimensional arrays, or you want to do anything that has to do with scientific computing in Python. So the first thing we're going to do is to create single dimensional array with the Numpy library. So here I have an identifier A, and I want to store an array in it. Now, to tell Python that this is an array, you need to use the Numpy library, and you can see that I have here A, the equal sign, NP dot array. Now array is in itself a function or an attribute in the Numpy library. So to call that is np.array, then whatever you want to put as the argument of the array, whatever data you want to store in the array, you bring it in the parentheses. So I'm storing here this list of 2, 4, 5 as array to this identifier A. So with this line, I'm printing what I've stored in identifier A. So I'm trying to show a comparison here. The same data which I've used here, 2, 4, 5, I'm also using it and storing it in B, 2, 4, 5 in B. So I'm equally printing B, and I'm printing the type of A and the type of B, just to show you what is the difference between using this np.array to pass in the same data and just passing in the same data directly into an identifier. So what class is A? What class is B? So let me run that before I explain it in space. Now you can see here that for the A, the 2, 4, 5 was printed without the comma. If you look at what we have here, A was np.array, and the list that was passed in there is 2, 4, 5. And when we printed A here, we can see that A was printed as 2, 4, 5 without the comma, telling you that that is an array. If you look at the B instance, the same list 2, 4, 5. When we printed B printed back with the commas, just telling us that this is just a list. is not an array. So arrays will not come with the commas, while a list will come with its own commas. So that's why you can only work with matrix in Python with the Numpy library. You can't just use the list to pass in a matrix in Python. You have to pass it in with the np.matrix. We'll still look at that as we go along, but just understand the concept and the difference between what an array is in the output terminal and what a normal list is. And if you look at the type of A and type of B, we can see here that the class of A is what? numpy.ndArray, which is a numpy array. And we can see that the class of B here is a list. So that tells you that this is a list, while this is so for the linspace, we have here y, which is an identifier, np.linspace. Now what linspace does is to create a vector of a specified number of elements. So what you specify in the linspace argument is the first value, the final value, and the number of elements you want in between this range of 0 and 20. Now this last entry of the argument is not the interval, is not the step, it's just the number of elements that you'd want. So I'm saying here that I want 3 elements between 0 and 20, just 3 elements. So if I run this now, Python will evaluate what the 3 elements should be. In this case, it's saying 0, 10, and 20. 0 will be the first value, 20 will be the last, and I'm saying I just want 3 elements in between from 0 to 20, which means it's only going to put in just one number more to make up that 3 elements. If I change this to 4 and I run this line again, I'll see now that I have 0, 6.6677, and 13.333 and 20. So Python will figure out what should be the number. So this 4 is not the step, but it's just telling me telling Python the number of elements that I want within the range of 0 and 20. So we have 0 as the first value, 20 as the final value. So Python will figure out what other 2 numbers should come in between to make up the 4 elements which are specified. If I change this to 5, 5, so this will run. So here we see it's 0, 5, 10, 15, 20. If I change it to 6 or 7, Python will figure out what should be the numbers that will come in between. So we can see 0 and 20 as the final, and Python figured out that 3.33, 6.66, 10, 13.33, 16.666 should come in between to make up the 7 elements which I said I want in between the vector I want to create. So that is for linspace. So okay, we talked about that already. Let me just do that again here. This is A, so this is Z, so this is just, so you can see here the initial is 5, the final is 100, and the number of elements that I want in between that range is 5 elements. So this one is saying 5 and 100 is the initial final value, and linspace function in Python figured out that 28.75, 52.5, 76.25 should equally be there to make up the 5 elements I want in that vector. So that is the linspace and the array. Now you can also create a multi-dimensional array. We already looked at a single dimensional array. In this case, I want to create an array that is a 3 by 3 array, 3 rows in this case, and 3 colon, 2, 3, 4 is 1 colon, 4, 5, 7 is another colon, 5, 6, 10 is the third colon. So that's a 3 by 3 array. So here I'm saying f is identifier equals np.array, then I'm passing in my data row by row. Now you can see that I have 2, 4, 5 in a list of its own, separated by comma. Then I have 3, 5, 6 in a list of its own, that's the second row, separated by comma. Then I have again 4, 7, 10 as the last row, and the final list bracket here, these 2, this and this. So that is the final list bracket, while other rows have its own list separately, so that can run appropriately. So you can see here. So that is first row, second row, and the third row. Because it's an array, you print here, say print bracket type F, and you run this line. So you can see that the class is an ND array. So that's an array, but that's a 3x3 array. Also, you can use the range function in Numpy. So here we have np dot range. So the range takes in as argument the first and final value, and if you have a step, you can put a step, but by default the step is 1. So this will give me 100 elements in this case, 100 elements in this case. So it will start from 0 to 99. 100 will not be there because when you count the number of elements from 0 to 99, you have 100 already. So that is why 100 is not printed in this case. So it's going to give me 100 elements from 0 to 100. So that is why you print this. Now you can see 0 to 99. So 100 is not printed because when you count 0 to 99, you already have 100 elements already, and that's the range I want. So if I step this by 2, I say I'm stepping in this case. Now in this case it's step, so you can see 0, 2, 4, 6, 8, 10. Unlike the list base, where is the number of elements that you want in the range, in the vector, for the range function, it is the number of steps or intervals you want in between the elements. That is the third argument. If I say it is 5, so it will be 0, 5, 10, 15, 20, and so on and so forth, like that. So that is, but it's still an array. If I print type this, you see that this is still an array type N. So you see that this is an ND array. So that's still an array. Also, we can decide to create an array, a multi-dimensional array with all zeros, or a single dimensional array with all zeros, depending on what you need. Now here I'm creating an array and I'm storing it in M, and I'm saying np dot zeros. So in this case I want all zeros in this array. So, and in this tuple I'm saying 2, 2, that is 2 row and 2 colon. So it's a 2 by 2 array. Also in this instance I'm creating an identifier X, and I'm saying np.zeros 4. In this case this should just be a vector of 4 elements in this case. So if you print this, so you can see the zeros, row 1, row 2, colon 1, colon 2. So that's the 2 by 2 zeros, and also the vector of 4 elements. You can see 0, 0, 0, 0. So that is for the vector. Also we can, let me create an identifier I and say np dot ones. In this case I just want all 1 elements, so I'm saying a 2 by 2, and I'm saying print, just saying I in this case. So let me just run this. So we see here that we have all ones in 2 by 2. So let me print, it's showing me that it's an array, but let me just use the print function alongside it. Print I. So we see first row, second row, first colon, second colon, using the keyword, the function ones and the function zeros, depending on what we want to print, or the array that we want to use. Also we can create an array from an existing data type. If you have an existing data type and you want to convert it into an array, for instance in this case I have an identifier U, and I already have this list stored into it, as 3, 6, 7, 8, 9. This is a list. I'm checking the type here, which will give me a list, and I'm printing U. However, I want to convert this U into an array. So I'll be using the as array function with Numpy. So, and I'm creating an identifier G. So I'm saying np.hasArray, and I'm putting in the identifier U in it. So these as arrays now will convert this list into an array and store it in identifier G. And here I'm checking the type of G, the type of class of G, and I'm printing G as well. So if I run this now we see the type of U is a list. You can see the output here is with the commas, and the type of G here is an ND array in Numpy, and we can see that the commas are not printed because this is an array while this is a list. So you can use the as array function alongside the Numpy library to convert an existing data type into an array in this case that we have explained it here. Now, another thing you might want to do with the Numpy is to use the reshape function, because with array you have a lot of shapes that you can get. Maybe it's a 2x2, 2x3, 3x3, 3x4, 4x1, 4x5, you know. So you can use the reshape function in Numpy library to reshape an existing array. So you have an array and you want to reshape that array, you can use the reshape function, because the shape that we're talking about is the number of dimension of that array. Is it a 2x2? Is it a 3x3, 2x1, 2x3, 2x4, 4x5, 5x5? That's the dimension. So once I've created an array, I want to change that shape. You use the reshape function with that identifier that stored that array. So in this case now, I created an identifier X, and I'm using the np.zeros to create an array of zeros of 16 elements. In this case, is zeros in the parentheses is 16, which means I'm only going to have a vector or a single dimensional array of 16 elements, which will be zeros. Here I'm printing the zeros stored in X. I'm just using this to separate my print. So that's why I'm putting this string of dotted lines here. Now, I'm using this identifier X underscore 3D equals this existing array X dot reshape. Now, the reshape in this case is not used alongside the NP because the X is already an array. So that's why I'm using the reshape alongside the identifier, because that identifier is already an array. So I don't need to use the reshape alongside the NP anymore because the X is already an array. So to know how to validly shape or reshape your array, whatever argument you are passing into the reshape function, the product of it must give you the number of elements in the initial array. For instance, I'm reshaping this vector of a single dimensional array of 16 into a 4x4 shape. If you multiply 4 times 4, that will give you 16. If you do 3, 4, it will give you an error because 3 times 4 is 12. So you can't reshape a vector of 16 elements into a multidimensional array of 3x4 because it will not work. So also here again, I'm reshaping again the same X here to 2, 2, 4. If you do the product of this, 2 times 4 is 8, 2 times 8 is 16. So it must always equal to the number of elements that you want to reshape. Anything other than that, it will find it difficult to reshape it. It will come out with an error. So in this case, I'm saying 4x4. That means 4 row, 4 column. In this case, I'm saying 2 row, 4 column in 2 places. So 2 row, 4 columns in 2 places. So that is what this expression here is saying. Now you can want to you might want to return to the initial shape of your array. In that case, you can use the ravel function alongside the array. Since the identifier is already an array, you can just say x.ravel. Then in this case, you don't need to pass any arguments in. The ravel function will take it back to the original shape that it was. And I'm storing that in R and I'm printing R. So let me just run this so that we can see the output. So the first thing I did was to create an array of zeros of 16 elements. This is what we have. This is the array of 0 of 16 elements here. So after that, I printed this line just to separate with dotted line. This is this line here that we have here, this line here. And I reshape this X here using the reshape function into a 4x4 array. So, and I stored it in this variable, this identifier, and I'm printing the identifier here. So you can see here I have a 4x4. Here, this is the reshape. This is the first row, the second row, the third row, and the fourth row. The first colon, second colon, third colon, and the fourth colon. So that gives me the 4x4 of it. Also, I did the 2, 2, 4. So this will be 2x4 in 2 places. 2x4 in 2 places. So that's what we have here. This is 2 rows, 4 colon in 2 places, another 2 rows, 4 colon. That is this shape here. Then I use the ravel function to return X to its original form, which is the single dimension of 16 elements, and I stored it in R and I printed R. So we see here that we got back the original shape here. So that's that. Now for further explanation of that, in this case I'm creating an identifier L, and I'm storing a range of number from 0 to 100. So I said I want 100 elements with this arrange function. So, and I want to reshape it into a number of possible shapes that it can get. Let me just comment all of this so we can see all the possible shapes that I can get. So let's explain them. So I have 100 elements. How can I reshape them? L is already an array, so I can use it directly alongside the reshape function without using the reshape alongside the NP anymore, since L is already in array form. So here I'm saying -1, 100. Now this kind of reshape, what kind of reshape would do for you? Because there's nothing like a -1 row. So what this would do for you is that after every element, the next element would be printed under the previous one. So you have a single colon in this case. So in this case, I'm only saying I want all the elements to be on a single colon. Since the row I put in here is -1, so the elements will be on a single colon. So -1, 100, that will be on a single colon. Now here again, I've done another kind of shape for it. If you multiply 4 times 5 times 5, 5 times 5 is 25, 4 times 25 is 100. So definitely I can reshape in this shape. So that will be 5x5 dimension array in 4 places. So that will be 5x5 dimension array in 4 places. Also, I created another shape here again. I said 2, 50. 2 times 50 is 100. So that means I can reshape in this form since I have just 100 elements. And 2 times 50 will give me 100. So that will be 2 rows, 50 colon. That's what this one will give me. Also, I'm doing here again 20, 5. 20 times 5 is 100. So I can also shape in this form. So I will have 20 rows, 5 colon. 20 rows, 5 colon. Also, I'm doing another shape here again of 25, 4. 4 times 25 is 100. So I'm saying 25 rows, 4 colon. So let me just print the first one, which is 5, 5. So we can see here the first one here, which is printing K here. This one is 5x5 in 4 places. So you can look at it row 1, row 2, row 3, row 4, row 5. 1, 2, 3, 4, 5. So that's the first one. This is the second one. This is the third one. This is the fourth one. So that is the 5, 5 by 4. So 5 rows, 4 colon in 4 places. So let me comment this and I'll comment this first line. I'm going to have just a single colon in this case. So we see here, sorry, a single row in this case. So we see here that I have it in this form. Also, let me just comment this out and do this. That will be 2, 50. That will be 2 rows. This is the first row. This is the second row. And 50 colon. If you count all of this, will be 50 colon. 2 rows, 50 colon. So that is what that is. So let me comment this out again and I'll comment another one. So that will be 20 in 5 places. So that will be 20 rows, 5 colons. So you can see 1, 2, 3, 4, 5. So this will be 20 rows. Now rows here will be 20 while there are 5 colons. So let me just comment that out again and do this one for 25,4. So we see here is 4 rows, 4 colon, 25 rows in this case. So that's another possible shape that you can get with it. So to reshape any array, you must be sure that whatever argument you are putting into your reshape parentheses must be equivalent to the product. The product of it must be equivalent to the number of elements in the original identifier. That is how you would do it so that you don't. For instance, if I change this to 3, 3 times 5 cannot give me 100. So that is why the reshape cannot be done in this case. It cannot reshape array of size 100 into shape 3, 5, 5, because the product of that will not give you 100. That's why that's impossible. So that's it. So anyway, you can also index the element in an array. You know, we talked about Python itself. It will index the elements in any identifier. So in this case, this is index 0, index 1, index 2, index 3, index 4, index 5, index 6, 7, 8, 9, and 10 in that form. So I'm storing that in R. So I'm creating a range using a range function to create an array from 0 to 20 or 20 elements, an array of 20 elements. I'm printing the array itself, and I'm using Q here to say Q is storing the value of the elements in index 6. So R square bracket, in that square bracket, whatever I put here in this square bracket is the index I'm specifying. I'm saying the value on index 6 is stored in identifier Q, and I'm printing Q. If we look at it, this is okay. Let me use an example that would, let me say I want it from 2 to 20. So here 2 is index 0, 3 is index 2, 2 is in index 0, 3 is index 1, index 2, index 3, index 4, index 5, index 6. So 8 is index 6. And we can see that 8 is printed here for Q. So what I'm saying here is that the element that is stored in index Q is also stored in identifier Q. So, and that is what I've printed here. So that is how you access index in Python with Numpy library. So here also I'm showing you, if you look at it all along, array has been printed on the vertical axis. So you can also tell Python how you want the array to be printed using the V stack for vertical print or the H stack for horizontal print. So here I've created an identifier Q with the list of 2 to 13 stored in it, and I'm using here the print function alongside the Numpy library to use the vstack function to stack Q in a vertical manner. You can see that Q here has been stacked vertically as an array, a vertical array. Also, you can use the horizontal stack, that's H stack, also for Q, to stack it horizontally. You can see here that we have stacked it horizontally. So you can use H stack or V stack alongside the Numpy library to tell Python how you want your array to be printed. So you can use a V stack for vertical stack or H stack for horizontal stack. Also, there's what we call slicing in Python. So slicing is not peculiar to Numpy. So slicing in this case is if you have a range of index that you want to access in a data, then you can slice the index of such a data to print elements in those index. There are two ways to slice. I will show you the first one with this, and I'll show you the second way or the second method with this. So for the first method, I'm creating an array which is using the range function alongside the Numpy library to create a 20 elements array and stored in R, and I'm printing R here. So I'm using the R underscore slice. This is the first method of slicing. So R underscore slice, you have to use it together like this. R underscore slice equals slice, which is a keyword in this case, or a function. And in the parentheses of this slice, you will tell Python what should be the initial, the final, and the step. So in this case, I'm saying from index 3 to index 15 in a step of 3. So whatever element falls in that category will be printed with this print line. So here I'm saying print R in square brackets R underscore slice. So it's going to print me the elements that falls in the range of index 3 to 15 in a step of 3 in this identifier R that I've created. That is the first method. So let me run that before I discuss the second method. Now, you can see here that the array function I've created this elements from 0 to 19, which are 20 elements, and I'm using this slice here to slice the index. So index 3 to 15 in a step of 3. So 0 is index 0, 1 is index 1, 2 is index 2, 3 is index 3. So from 3 here to index 15, a step of 3. So this will not be printed, this will not be printed. The third step is 6. This will not be printed, this will not be printed. The third step is 9. This will not be printed, this will not be printed. The third step is 12. So this will not be printed, this will not be printed, this will not be printed, because at that point it has reached the last element. So that's why I have 3, 6, 9, and 12. So this is index 0. Okay, let me change this to, let me put 2 to 20. So in this case 2 to 20. So this is index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, index 9, index 10, index 11, index 12, and by the time it's counting index 13, index 14, index 15, which is the next one, that's already gone beyond the final value which I want, which is 15. So it will not be printing what comes beyond that one. So that's the first method of slicing. The second method is this. In this case, I just want to say, okay, I want to print the element that falls from index 2 to the end. So R square bracket 2, index number 2, colon. I'm not putting anything after the colon, which means from index number 2 to the last element, print it for me. In this case here, I'm saying R square bracket I'm not putting anything before the colon, and after the colon I'm putting 8. So I'm saying that everything from index 0 up until index 8 print for me. Everything from index 0 to index 8 print for me. In this case, I'm saying print for me everything between index 4 and 8. That's what I'm specifying here. Print for me everything between index 4 and 8. And we'll look at this here. We saw that index 2 to the end. So 0, 1, 2. Index 2 is 4. So 4 is starting here. To the end, the last value here is 19. So that's why it's up until 19. In this case, I'm saying everything up until index 8, from index 0 to index 8. So you can see that 2 have started here, because 2 is the first index, that's index 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now you can see that this 0, 1, 2, 3, 4, 5, 6, 7. So the last value is not printed. That's how the range function operates. Also, everything that falls between the index of 4 to 8. So 0, 1, 2, 3, 4, 6 is the fourth index, and that's been printed here. So 4, 5, 6, 7. So you can see here that it is between 6, 7, 8, and 9. That is in that range. So that is what that has printed here. So that's the two methods of slicing. Now you can want to check the attributes of your array. In this case, you just want to know, the shape of your array, you want to know the number of dimensions of your array, and you want to know the item size of your array. So here I have a multi-dimensional array which I've stored in identifier W, and I'm using print W to print the array, and I'm using print W.shape. Here I'm using this print W.shape to print for me the shape of array that is stored in W, which means once is number of row and column that is there, that's the shape. So in this case I have a 3 by 3 array, because this is my first row, this is my second row, this is my third row, and 2, 3, 4 is my first column, 4, 5, 7 is my second column, then 5, 6, 10 is my third column. So that's a 3 by 3 dimension array. So the shape will give me 3 by 3. Now the W.end dim, this W.end dim will tell me if it's a single dimension or a multi-dimension array, and whatever it is, if it's single it will tell me it is 1, if it's double it will tell me it's 2. So the item size is just the bit size, the memory space is taking. Now what the item size is telling me about the data. So if you look at it now, the W, print W here has printed the W, what I've stored there, back. You can see that the shape is telling me it's 3,3. Number of row and column that is in that array, that's what the shape will tell me. So that's number of row and column 3,3. Now you can see here that the dimension here is a 2-dimensional array because it has row and column. So that's why the end dim is 2. And 4 is the item size, that's the bit size is taking up in the system. So here I'll be showing how you can read and write ROM or to a text file using the Numpy library in Python. Alright, so here I have already the array here, which I've created a 3 by 3 array and I've stored it in queue. So I want to use the Numpy library to save this as a text file to my desktop. So I'll be using the np.save.txt, save.txt alongside the Numpy library, and in the parentheses I'll be giving the path and the file name I want it to have. So my C drive / my users, then name, desktop, then class, this is the file name, this is pyclass.txt is the file name, comma, this is the identifier which I'm storing its value into this text file with this file name. This is the file name in this case. However, all of this is the path to where it is, so it's going to be saved on the desktop. And I'm also reading that file using the load text alongside the NP library, storing it into an identifier Y. So for the load text, I'm only going to specify the part of the file in the load text. So if you run this, so you see this is Y being printed, and Y is printing exactly what you have in Q. And if you go to the desktop now, you can see that this is the text file here that has been created on the desktop. That's the, so let me delete this so that you can see that it's been created again. So let me just run this again and go back to the desktop and see that that has been created again. So that is how you read and write into a text file on the system. Just by now, you can also use the CSV format. Aside using the text format, you can use the CSV format. So let me just copy this part here as the CSV format of it. So CSV, let me copy this part again. Okay, so for the CSV, I'm using the same instance of array, but I'm using identifier A this time. So np.saveText, this is the part in this case. However, this is the file name, and the file type here is the CSV file. So this is the file name in this case with the .csv, which is a CSV file. So this is the data I'm storing in it. Now, because this is an array, I'll be using the comma delimiter of Excel alongside it. So the delimiter here equals then string comma is the delimiter in this case, because I don't want this comma to appear in it. So that's why I'm using this delimiter comma alongside it. So it's only be the values that would be taken. Also, I'm loading back that text and I'm saving it into identifier B with np.loadText. Let me take this out. This is wrong. So this will load the text back. So let me just read this. So you can see B is being printed and it's printing exactly what I have in A. So let's go to the desktop. You see this is the CSV file. Let me just open it. We'll see the text. You can see this is the text in the CSV file. The same thing with the text file. So you can see this is the text file that we created earlier. So that is how you read and write text file and CSV file using the Numpy library. So also you can work with matrix with the Numpy library. So here I'm creating two matrices A and B. So this matrix A, this matrix B, using the np.matrix. Now in this case I'm not using an array because this is a matrix, so that Python understands that this is a matrix, not an array. So np.matrix 3 by 3, 3 rows and 3 colon. Also the B is also a 3 by 3 matrix, and I'm using the mathmul function here to multiply the two matrices together. So np.mathmul, in parentheses, the argument will be A, comma B. So, and I'm storing it into identifier C, and I'm printing C here. So mathmul A, comma B will multiply matrix A by matrix B. And the rule of matrix is that for you to multiply a matrix, the number of row of the first matrix must equal to the number of colon of the second matrix. Without that, you cannot multiply two matrices together. The number of row of the first must equal to the number of colon of the second. So in this case, I have 3 rows here, 3 colon here. So this will be able to multiply. The number of row of the first must equal to the number of colon of the second for you to be able to multiply them. So that's mathmul. Also, you can transpose a matrix. Transposing a matrix is just changing the row into colon. So whatever is the row will be the first row will become the first colon, the second row will be the second colon, the third row will be the third colon when you use the transpose. So Because B already is a matrix, I can use transpose alongside it. So B dot transpose, I don't need to pass in anything into the argument. So that would transpose B and store it into C. And I'm printing, sorry, into D, and I'm printing D here. Also, I'm doing here again, F is a matrix, however, is just a row matrix. So just a single row of 3 elements. So I'm printing F here, and I'm transposing F in this case so that this row becomes a colon. So with that, I can multiply A comma Q, because Q, let's go back to what's Q. So okay, so Q is the transpose of that. So A is a 3 by 3 matrix, 3 row 3 colon. So for me to be able to multiply A with another matrix, the number of row of A, which is 3, multiplies the number of colon of the second one. So row times colon or colon times row, whichever one, so that it can match. So print G. Then this one also, let me just comment this out, is doing the same thing of multiplying A times B. So let me just comment that out. Now we see here, this is the product. This is the math model of A comma B. This is math model of A comma B. And the transpose of B, which is stored in D. So 245 will become 245 as the first row. 356 will become 356 as the second colon. 470 will become the third colon as 4710. And that is what has happened here. 245, 356, 470. That's the transpose of B. So this is F. Printing F, transposing F. This is F itself. This is F itself. And after I've transposed F and stored in Q, I multiplied it with A and stored in G and printing G. So this is G, which is now a colon vector because of what I've done there. So all of this we have seen. So we have seen all of this already. So with that, we have come to the end of this class. Thank you very much.